Thinking Like a Geographer, Unit 1 Notes. Just what is geography? Plainly defined, it's the study of the physical features of the Earth and of human activity, including the distribution of populations and resources, land use, and industries. A lot of times geography is called the mother of all sciences because it incorporates so many other fields of science into its studies. There are two major branches of geography, both physical and human geography. Physical geographers are they find most important the spatial characteristics of elements of the physical environment. Human geographers are most concerned with the spatial characteristics of humans and human activities. Subfields of human geography include culture, whereas geographers would look at the distribution of language, religions, population geography, political geography. Urban geographers would look at things like the cities, the growth of suburbs, and problems associated with that growth, and then economic geography. Geographers use the spatial approach to look at the world. And spatial really just means relating to or occupying a space. It's just a way that geographers look at things. And geographers want to consider the location, the distance, the patterns, the interconnections. So why is Hayworth located in the place that it is? How does its distance to Bloomington impact the population distribution and who lives in Hayworth? And how are Hayworth and Bloomington interconnected? Geographers are also concerned with the movements of places and things. Like, how does language spread and how does language change in places over time? And geographers ask a number of different questions. For instance, why are things where they are? So why is the largest city in Illinois in the northwest corner of the state rather than the center of the state? How have things become distributed in the way that they are? Like, why does New York City have a higher population density than Los Angeles? What is changing patterns of distribution? Like, why are so many people in Central and South America moving to the United States or trying to migrate to the United States? And what are the implications of the spatial distribution for people? How does the population distribution in Illinois impact electoral politics in this state? How does it impact how we vote for president? Geographers use a number of tools, but maps are by far the most important tool for geographers. Geographers not only use maps for the analysis that they are going to complete, but they also use maps to display their findings. And any good map has to have a scale. And the scale of a map is just the ratio between the size of things in the real world and the size of those things on the map. And scale can be related in three different ways. The first of which is cartographic scale. Right? It's just the communication of the ratio of its size to the total size of what it represents. And cartographic scale can be shown in two different ways, the ratio and in words. So ratio would be something like 1 to 200,000. And that just means that one unit of measurement is equal to 200,000 of the same measurement. So for instance, if we were using inches on a map, 1 inch would be 200,000 inches in the real world. Similarly, if we were using centimeters, 1 centimeter on that map would equal 200,000 centimeters in the real world. Cartographic scale can also be used, can be displayed in words. For instance, 1 inch equals 10 miles. And if it says 1 inch equals 10 miles, then we know on that same map that 2.5 inches would equal 25 miles. And this type of scale can also be shown as linear, as we see, a line. If this were to be measured out to 1 inch, then we would know that 1 inch would equal 6 miles. And more often than not, this is the type of scale that you're going to see on a map. We also have geographic scale, which is also sometimes called relative scale. And this is just showing the amount of territory that a map is representing. So we can have a map of global scale, which is a map of the entire planet. Local scale would then be on a much smaller level, like the map of a city or a neighborhood, or even just your yard. The smaller the map, the finer the details that you will see on that map. The scale of the data is just giving us the level at which the map data displayed is shown. So if we look at these two different maps, they're both showing us population density. One of these maps is showing population density at a country level, and this map is showing us population density at a county level. So this map is showing us that our population is distributed pretty moderately throughout the eastern and southwest portions, whereas the map at the country scale is showing us that our population really just distributed higher on the coastlines rather than inland. So that gives us a different idea about where people are living in the country of Australia. You can see the smaller the detail of the scale of the data, the more information that we have. There are lots of different types of maps that exist. Reference maps are maps that are designed for people to refer to for general information about places. Things like political maps, which just show us our human-created boundaries. Physical maps, which give us our natural features like mountains or rivers or lakes. And then we also have like road maps are considered reference maps. So we can figure out directions from one place to another. Another category of maps is thematic maps that give us spatial aspects of information. And there's four main types of thematic maps. We have choropleth maps, which are using various colors or shades of one color or patterns to show the location and distribution of spatial data. So for instance, the map that we are looking at in this presentation is a choropleth map that is showing our 2010 per capita CO2 emissions. And as we can see from the legend, the darker the color, the higher the emissions. And sometimes you'll see this as different colors, but a lot of times on a choropleth map, you're going to see all of these colors being a different shade of the same color. And usually you will see as colors get darker, the number that it's representing is increasing. Next, we have a dot distribution map, which is a second type of thematic map, and we are looking at a dot distribution map here in this presentation. And this specific map is showing the location of libraries in the Northeast. Specifically, we're looking at New York City and into New Jersey and even in Pennsylvania. And on a map like this, we're looking at one dot equals one library, but sometimes on dot distribution maps, maybe one dot equals 5 libraries, but it's just showing us how densely distributed is something, and that's the main point of a dot distribution map. Symbols can also be used on these maps instead of dots. So maybe if I wanted to make a dot distribution map of the number of libraries in Illinois, I could use the symbol of a book instead of a dot. Next, we have the graduated symbol map, which is shown here, which our graduated symbol being a circle, and this map is showing us our U.S. oil consumption barrels per year by state. And on a graduated symbol map, these maps use symbols of different sizes to indicate different amounts of something. So generally, the larger the size of the symbol, the more of whatever is being displayed is being used. So for instance, on this map, the bigger the circle, the more oil is being consumed by the people of that state. So we can see by far in the United States, just looking at this map, regardless of the number, Texas is the highest oil consumer in the United States, followed pretty closely by California. It's easy to see where the largest and smallest phenomena are happening in graduated symbol maps, and that's the main advantage of using this type of map. The fourth type of thematic maps are isoline maps that use lines to connect points of equal value to depict variations in the data across space. So it's showing the different areas that have a certain characteristic in common. So this is a map that's showing the United States and the different average temperature in the United States. So you can see that the places that have the same color generally have the same average temperature over time. And the closer these lines are together, that generally means that that's changing rapidly. That's not as stable and could change. But if there's a pretty big distance between lines, that generally means that there's not a lot of changes that are happening inside that area. We also have cartograms, which are shown here. We have 3 different cartograms showing different stores that exist in the United States. And cartograms generally just show the sizes of countries, states, counties, cities, whatever's being shown. This map is showing us states. And it's shown according to a specific statistic. So the specific statistic that's being shown at the state level here is the number of Walmarts, the number of McDonald's, and the number of Starbucks. So the bigger the state being shown on this map, the more of that store that exists in that state. So for instance, if we look at the Walmart map, we can see that Illinois actually has a lot of Walmart stores because it is being shown very large. It's being shown much larger than Texas and even pretty equal to California. And California is a much larger state than Illinois. So our distribution of Walmarts is much higher than that of California. If we look at the McDonald's map, we can see the Midwest is very, very large, has a very large amount of McDonald's in contrast to maybe some of the states in the Rocky Mountain and the Great Plains. And then if we look at the Starbucks, California and the West Coast by far has more Starbucks than we would say even maybe the Southeast, because those states are being shown at a much smaller size. So all of the maps that we look at are projections, right? And they are all showing a curved surface on a flat surface because the Earth is round. No flat earthers allowed. The Earth is round, and putting that curved surface and making it flat is a very difficult process, and it's actually nearly impossible. So all maps have distortions. There are 4 main map projections that geographers use. The 4 major ones are the Mercator, Peters, Koenig, and Robinson projections. The Mercator map, which is this map right here, its original purpose was for navigation because the lines of latitude and longitude meet at 90-degree angles. And in the Mercator map, the direction is very accurate. But the land masses at the poles appear much larger than what they actually are. So we see like the country of Greenland, the island of Greenland, is being shown as about the same size as Africa, and Greenland in all actuality is much, much smaller than Africa. The Peters projection, which you can see here as well as on the north wall of Mrs. Sadilek's classroom, is a map that shows the size of land masses accurately. But the shapes of those land masses are distorted at the poles. So like the shape of Canada is actually pretty distorted here at the poles, and you can't even see Greenland. But it is showing accuracy in the sizes of land masses. And then we have the Koenig projection, where we see size and shape are mostly accurate, but our direction isn't constant. And then the Robinson projection, which you will see on the south wall of Mrs. Sadilek's classroom, there are no major distortions, only slight distortions in area, shape, and distance. So how do geographers do what they do? A lot of geographers use observation and interpretation. We call this geospatial analysis. And geospatial analysis, geographers will want to collect geospatial data. So any information that's tied to a specific place. And they can do this through landscape analysis, where geographers actually visit a location. They actually go to a location and take down as much information as they can. They take notes, maybe they sketch maps, they may count or measure things, maybe they interview people that live in the area, and they can also consult census information or look at land surveys. And this is what geographers did for a really long time. Modern fieldwork has really been improved by technology. Geographers can now use remote sensing, aerial photography, ground level photography. They can take sound recordings, do chemical analyses of air, water, soil. And so geographers might be interested in understanding what changes are likely to occur as people move into or out of an area. And they will try to interpret that information as best they can, pull together collected information to better understand the area that's being studied. Maybe ask questions like, who are the people that are migrating into this area? Who is leaving? What are the cultures of these groups of people? What effects will those changes have on the local economy? What are the causes of people moving? And what are the types of human-environment interaction that are occurring? How does an increased presence of humans existing in this area impacting the ecological systems that exist in this area? And as I said before, technology is really making fieldwork a lot easier for geographers. Geographers use a number of different technologies to do their jobs. Geographers use global positioning systems to use the location. And so global positioning systems generally use a series of satellites to determine a person's exact location. Geographers would use this to precisely locate borders. Not all borders are physical. Some borders are straight lines, and GPS can help us determine where exactly those lines hit on the actual Earth rather than just looking at a map. GPS can also be helpful in navigating ships and aircraft and cars. I know anytime I'm driving someplace new, I have to put the address into my Google Maps on my phone, and that's GPS, and it gets me to where I need to be. It gives me my step-by-step directions. Hikers also use GPS. We can see this Garmin right here in the presentation. Hikers use this a lot of times to map out trails or understand the topography of a region that they're hiking in. Also, if you've ever done geocaching, that is also used with GPS systems. Remote sensing is the use of mounted cameras or sensors to collect digital images of the Earth's surface. These are used by geographers to determine land cover and use. Is the land being used for agricultural or industrial purposes? Possibly geographers are monitoring environmental changes, things like erosion or flooding. Or it could also be monitoring the weather of a certain place. Geographers are also using geographic information systems, and this is something that you're also going to have a chance to use. But it's a computer system that can store, analyze, and display information from multiple digital maps or geospatial data sets. And these can be especially useful to help geographers solve problems. Like, for instance, if I wanted to build a new airport in central Illinois, I would have to look at a number of different layers of information. I would want to know where the water features are, like, because I don't want to build an airport on top of a major stream that's a tributary to a river. I also don't want to build this in an area that has a lot of people living in the area. It needs to be pretty remote. I also want to build it in an area that's going to have ease of transportation, and I also want to have a lower elevation, or at least a flat elevation. I don't want to build my airport in a space that has a lot of hills. Airport runways don't work super well when there are a lot of hills. And so I can take, in a GIS system, I can take all those different levels of map information and layer them together to find a perfect space to build an airport. It just allows geographers to see spaces in different ways and to kind of manipulate, turning layers on and off in order to see the information in different ways. So geographers might use GIS to analyze crime data, look at the effects of pollution, look at transportation or travel time analysis, and it can also be used for urban planning.